Hello, this is Mr. Boshin with our lesson on sets of real numbers. There are multiple numbers within the real numbers system. We must know what those numbers are. So first of all, we'll start with the first number that you have all known for your whole life. These are called natural numbers. Natural numbers are 1, 2, 3, 4, also known as counting numbers. These numbers are numbers you've been using since you were a little kid. Just didn't know that the number of them were called natural because they come to us naturally. Next numbers are whole numbers. Whole numbers are similar to natural numbers except you include 0 because the natural numbers, 0 doesn't come to us naturally because it's hard to think of 0 or it's hard to think of nothing because you don't have nothing tangibly. You touch stuff. You have one computer. You have pillows. You don't think of not having anything. So 0 is something that's not tangible. It's something you think of because it's something you don't have. And you come to integers. Integers is when you start using negative numbers. It's positive and negative whole numbers. As you see right here, you got the positive and the negative whole numbers right there. There are no decimals yet. So far, rational numbers have been natural, whole, and integer. The last one is when we start adding in decimals and fractions. This is called the rational number. The rational number, these are numbers that can be written as a fraction or a ratio. This is 1/3. This is 2/5. This is 1/2. All of those fractions can be written as a rational number. Let's go through a few examples. Before we do that, we need to look at the real number system. As you will see, real numbers are broken down into different types. There are two types. There are rational and irrational. You'll see over on the irrational side, there's only irrational. There's irrational and there's a number pi, square root of 3, and etc. Over on the rational number side, rational numbers are there, and then inside of rational numbers are integers, inside of integers are whole numbers, and inside of whole numbers are natural numbers. So as you see, there are multiple things within this system. Rational is all integers are rational numbers, but is there anything under irrational? No. Now I do want you to point out that there's this thing called imaginary numbers. It's over on this dotted line. You don't have to worry about imaginary numbers now at this time, but just as a heads up, imaginary numbers is something you'll get to when you get to college. But those are something that's out there. It's made up numbers essentially. Okay. Now let's do an example. We need to write all names that apply to each number. I want you to try this out. Try to come up with what kind of a number this is. You should be able to see it right away. Okay. -10. What type of number is this? Okay. -10. I'm hoping you guys all said integer because it's a negative number. But it's more than just an integer. It's also rational and it's also real. If you remember when we go back, if we go back and look at our chart, integers are within the rational number system. So integers are all integers are also rational numbers, and all rational numbers are also real numbers. Okay, that's important to know. So -10 is integer, rational, and real. Let's look at B. 12/3. Since it's a fraction, we know something about it, that it has to be what? Rational. It has to be rational because it's a fraction. But you must divide it. What's 12 divided by 3, everybody? 12 divided by 3 is 4. So since 12 divided by 3 is 4, that makes this a natural number, a whole number, an integer, a rational number, and a real number. Actually, on there they forgot natural. Isn't 4 a natural number? It's a natural counting number. So natural should be on that list also. But it's whole, integer, rational, real, and natural. So what they're asking you to do in these situations, they're asking to give you as many possible ways to describe it. Could you describe this as a rational number? Yes, you could because it's written as a fraction. Well, all rational numbers are also real, so you could also explain it as a real number. since it's a whole number, that's automatically makes it an integer because all whole numbers are integers. Okay, moving on. Tell whether the given statement is true or false and explain your choice. Here it is. No integers are whole numbers. Are any integers whole numbers? This says no integers can ever be a whole number. Well, if you think about it, is 1 an integer? Yes. Well, is that also a whole number? Yes. So this must be false. Every whole number is also an integer. So there are some integers that are whole numbers. So you can't say no integers are whole numbers. These types of questions are very tricky. We got to think through them. And the great thing, what I would do, is I would go back to this slide right here, and I would draw this diagram. Make sure you know that rational numbers includes integers, and inside of integers is whole numbers, and inside of whole numbers is natural numbers. It's very important that you know that all natural numbers are also real numbers. Okay, sorry, let me get back to the slide. I went all kinds of crazy on a rant. Oh, yeah, okay. Now, write the names that apply to this number. Now, the important thing to know is this is something that I really didn't explain when we were at the real number system, but you'll notice the decimal is repeating. If the decimal repeats, that means it can be written as a fraction. So if it can be written as a fraction, what type of number is that? That is a rational number. Also, it's a real number, because all rational numbers are also real. All numbers that we're talking about right now are real numbers, so you're going to have to put real into the system. The only numbers that aren't real are imaginary, and imaginary you don't talk about until you get to college. Okay, let's look at number 2. Tell whether the given statement is true or false. Explain your choice. All numbers between 1 and 2 are rational numbers. Are all numbers between 1 and 2 rational numbers? The answer is false. Square root of 2 is an example of an irrational number. Square root of 2 equals, let me do it here on my fancy dancy calculator. Let me do it right here. Give me a second here. 2 square root. It is 1.414. And it keeps going. You see how it keeps going? Because the decimal does not end and it does not repeat, that makes it irrational. Therefore, not all numbers between 1 and 2 are rational numbers. Okay, let's look at number 3. Identify the set of numbers that best describes the situation, and then explain your choice. Choices on survey questions change the total points for the survey by -2, -1, 0, 1, or 2 points. So is this, what type of set of numbers is this? Is it whole? Is it integers? Is it real? And you're trying to find the one that best describes the situation. So we're not naming all of them, we're trying to find the one that best describes this type of situation. Look at the numbers. Are there decimals or fractions? No. So can it be rational? It is a rational number, but that does not describe it best. What describes it the best? They're positive and negative whole numbers, which is a integer. Each number is an integer, but only 3 are whole numbers, okay? Also, they're all rational, but best describing is integers. That is it for today's presentation. I hope you understand the real number system a little bit better. And until next time, this is Mr. Boshin signing off.